Welcome to our tutorial on building an interactive data analysis tool using Streamlit. In this video, we walk you through creating a powerful data analysis application that allows you to upload datasets, handle null values, and visualize data with ease. Whether you are a data scientist, data analyst, or just curious about data, this tool will be a game changer. Let's dive in. Hello everyone. Today we are going to build an interactive data analysis tool using Streamlit. This tool will help you to handle null values and everything about the data visualizations also. So first I will show how it will look and how it will works. Then we are see how to code it. Okay. First, this is the tool we have done with our PyCharm, and I have run this using the Streamlit platform. Okay, let me show you. This is the interactive data analysis tool where I can upload CSV, Excel, or JSON file. Okay, and let me use one. Okay, here I am going to use this sales data.csv. You can see multiple videos on YouTube. There they have shown this tool or Streamlit tool to visualize data, but everyone is doing the same, that they are using the one data set and showing that this Streamlit is used for data analysis and they are only using one data set. But I am not doing that. I have done, or I have created this tool to visualize multiple data sets and with different data sets. This is not fixed for one data set. Okay, after uploading this data, sales data.csv, here we can see that. After that, we are going to preview here that raw data preview. That means as it is, the data is shown here. Okay, then the data insights, it shows that data set shape. That means it has 174 rows and 6 columns, that 1 2 3 4 5 6 7. Okay, first is the index, so we can neglect that. Okay, then data type of each column with the column name. Date column is having object, product is having object, category is having object, sale is having integer value, revenue is having float value, and then region is having object value. Okay, then some statistical numerical columns. Okay, first this is for the statistics, that is we are doing this with using df.describe. Okay, and this is the categorical column analysis. Okay, I think we have missed here, but we will correct that in the coding. Okay, then here you can see unique columns in date. So how many unique columns have date? So it has only one column unique. Okay, in the product it has two products, different products, and having count of 87 each. Then the categorical, so in category it has two unique values, that is electronics and food. Same for region, it has 3, and here we can see the missing values. So here are no column has a missing value. Okay, then here a data cleaning tool where we are going to change or replace our null values. Okay, we are using here none, mean, median, mode, or custom value. Okay, then when we click on applying null handling, it will change it. Okay, then you can see here we have plot here, one bar plot with date and sale column. We have here multiple plots. You can add anywhere. You can add here graphs, whatever you want to. Okay, then let's move to the next. Here on x-axis it has all columns, on y-axis it has only numerical columns. Okay, then here for color we can use multiple, okay, so columns here. Okay, then here we can change aggregate values. If we can use mean, we can use sum, we can use count also. Okay, with that it will change. Okay, then we can change here plot also, so it will plot accordingly. Okay, then let's, okay, it's not showing because of it needs to add. that type of values to plot this graph. Okay, line plot. So basically we are going to plot line plot. Okay, it did not plot with the category, sorry, product, sales. Okay, is plotting. I think it did not have that type of values to plot this graph. Okay, okay, that's it. Then here we are using data filtering. Data filtering means what kind of data or what kind of what number of columns we want in our last dataset to download this filtered dataset as CSV. Okay, so we can change here, we can remove column. Okay, after we remove here one column, okay, we'll remove revenue column also. Okay, you can see here revenue column is removed. We can add also, add from here revenue, and the second one is region. Okay, automatically it will added here, and then we can download it from here. Okay, you can change it with the dataset type also. Okay, okay, that's it. Okay, let's see how to code this tool. For that I am using PyCharm. Okay, you can see here. Okay, let's move. For this we are going to need 4 libraries. That is, first one is Streamlit. Okay, let me show you Streamlit. Then second one is pandas. Okay, then third one is numpy, and lastly we are going to use plotly to plot multiple graphs or multiple plots. Okay, you can install it on a terminal or command line. After that you can use it easily. Okay, I have already installed these libraries with my PC, so I am not going to use or install this. Okay, let me, okay, here is I'm having command line. Okay, let's code. Then let's see how you are going to code this. Okay, sorry. So these libraries will help us to build an application and handle data operations. Once we have installed them, we can move on to write the code. Okay, let's start by importing the necessary libraries, and open your favorite code editor and create a new Python file. We'll begin by importing the libraries we need. For that, as I said, we need 4 libraries here. So first is Streamlit. We are going to import Streamlit as st. Okay, then import pandas as pd. The next import import plotly dot express. Okay, I'm having here express as px. Okay, then lastly we are going to import numpy, import numpy as np. Okay, so these 4 libraries we are going to use in this coding. So I will explain you how these libraries work, or why or what kind of works these libraries are doing. So first, Streamlit, a framework for building interactive web applications with Python. So Streamlit is basically used for creating a frame, or it is a framework that is used for building an interactive web application. Second, pandas. So pandas is a library for data manipulation and data analysis. Okay, then plotlist.express. So library, it is a library for creating interactive plots and visualizations. Okay, and numpy. So numpy is basically used for numerical expressions or numerical operations. Okay, then first we are going to load our data. The first thing first, we have to load our data set here. So for that I am going to create one function, dev load underscore data. Inside of that we are passing file, then enter. So what we are going to load data from different file formats. So it has to accept different kind of data set. For that we are going to use try and except block, so it will handle error also. Okay, so all the code or multiple times we are going to use try and except block. So our code will handle all the errors will come through that. Okay, so I'm using try here. Try, inside of try we are going to use first file extension. So as file extension, so which file extension we want? File. So as you can see here, we are passed a file inside bracket. So file dot name dot split. Okay, split. So inside of that we are going to pass what? A dot. Means that if the file name after dot, I'll show you here. Here you can see that sales data, sales underscore data, as here it's dot. So it will separate it from here and check. When check, after lowering it, so after the lowering it, it will easily handle capital values also and smaller values. So we have to this, then what? -1 from last one. Okay, what? It needs to be lower. Okay, so we are up to what? We are up to handle this or handle the error. Okay, then what? Then we need, or basically what? This function defines load data to load data from a file. Okay, then extract the file extension from the uploaded file name and converts it to lowercase. This helps us in identifying the file type. Okay, so it will help us. I'll show you the full code. Okay, here I have plotted or write all the code. I have done this and created this. So I am going to plot this for you. Okay, and showing you with you. Okay, then enter here try with try. Okay, if what? File extension, this file extension. Okay, if file extension what? Is equal to what? CSV. What we can say? What it has to do? If the file extension is CSV, then do what? df is equal to what? pd dot read underscore CSV. Okay, this is a pandas command which is used to run or which is used to read CSV data, and what inside of that we are passing file value. Okay, so what basically what is file? File is this. So this, what is this? This is a file, or the file we are going to upload on our web page. Okay, so here we have used or write a code which is handle our if value. After that you can see here we have written all the code for if, xlsx, JSON value, and then handled error here also. Okay, let me write this. Okay, let me correct this first. This is going to be tab, this is going to be inside. Okay, enter. Okay, same that we are going to use elif. Why we are going to use elif? Because we want to add here multiple conditions. So, okay, then in elif we are going to use file extension. Okay, if the file extension in what in, so with Excel value or Excel file we are going to get two extensions. That is, one is xlx and the second one is xlsx. Okay, so for xls and the second one is xlsx. Okay, so we are going to handle here both the values. So below that we are going to use df is equal to, okay, df is equal to pd dot read underscore xl. Okay, pass what? File. Okay, that's it. We have passed a file. Okay, below that. So what we left? We can handle here APIs also. So for that I am going to write elif. Sorry, elif file extension, sorry, file underscore extension in bracket what? Sorry, or we can use here is equal to. Okay, So file extension is equal to what? JSON. So JSON will handle our API values. So for that I'm using JSON extension. Okay. So how to read that in pandas? So we can use pd dot read underscore JSON. So it will read our API to handle datasets. Okay, let's move to the second part. What second part? We are left with our else value. So how else is going to help us? So else is going to help us with our error value. So inside in the else we are going to write st. So basically what is st? St is used for our Streamlit code. So st dot error. So what? It will show the error on the Streamlit web app. It did not stops working. It will show error there and it will start in a working condition. It did not stop our code. Okay, what kind of error we are going to use there? That is unsupported. So basically we are going to say to user that this is an unsupported file format. Okay, that is unsupported file format. That means the user needs to add the file which has extension .csv, .xlsx, .xls or .json only. Okay, that is unsupported file format. Then please upload what? CSV, comma Excel or JSON file. Okay, this is the error we are going to show user, or return or not. At that time, if he gets an error, what value or what the thing he has to show on a web page? That it has to show none. Okay, that's it. So let's see what we have done in this code up to now. Okay, so here in this code sorry, for file reading we are depending on the file extension, okay, to read the file into pandas data frame. So we are using here file extension to read our datasets or file. So CSV will read here CSV files using pd.readcsv. For xlx or xlsx, which reads an Excel file using pd.readexcel. JSON, which will read a JSON file using pd.read_JSON. And the last, if the file format is unsupported, displays an error message using st.error and return none. Okay, then let's head towards the next. So what is next here? We have write def here, we have write try block, we have left with our next coding. Okay, then what we want in return? So in return we want a def. So it has to return a def. Def means it has to return a def value. What def value? You can see here when we upload a dataset here, it needs to show this def value on web page. For that we are going to use here that says that I want a def on our web page. Okay, return def. So below that we are going to write that except. What except? Except an exception as e. So inside of the extension we are going to write st.error. So inside of error we are going to write that we are going to use error loading file. Error loading file with curly braces str in regular bracket we are going to use. So it will show what kind of error is or what kind of error has to be displayed, or return none. That is file handling, or sorry, try and block we have used here to handle our exception or error without losing our web page on live page. Okay, so error handling, what error handling? Error handling will catches any extension or exception that occurs during the file loading and displays an error message using st.error and returns none if an error occurs. So here we have also write that if this file has no extension with the CSV or all this from all these four, then it will error, shows an error. Okay, even after that also we are going to get an error. It will shows that the error file loading, then the error from our terminal. Okay, okay, that's it. Let's move to the next line. That is what next line we have done. That is we are going to use or code all these lines. Okay, for that I am going to write code one by one. Okay, let's write code for clean data. So what clean data, or what kind of clean data? Let's see. First, def clean data. In a bracket we are going to pass df. So below that we are going to pass for column in df dot columns. Okay, it will seen, it is a simple pandas command. So what, for column in df dot columns, enter. Below we are going to write if df of columns, sorry, df of column dot d type. Okay, if the columns data type is equal to what, object, then what, then again we are using here try and except block. What, try, what is inside try? Numeric. We are going to use numeric values is equal to pd dot to numeric. Okay, inside of that we are passing df of columns. Okay, df of columns, sorry, df of column out of square bracket errors. Okay, errors is what we are going to write is course. Let me write it first, then I will explain you. Okay, and what if numeric values, what, these numeric values dot not na, so it did not have an na value, then what, dot sum divided by length of numeric values. Okay, less than 5. Okay, so below that we are going to write df of columns. Let me write it first. I will explain each line carefully. Let me write it first. We are left with the 2 lines of code only. df of columns or df of column is equal to numeric column. So it will take column as a numeric column. Okay, so below try block we are going to write except block, sorry, except what, to continue it. Okay, if there is an error you have to continue up to end. Okay, and enter. Below the for block we are going to write we want df. Okay, so let me explain first. The function defines a clean data to clean and prepare the data. Okay, after that data type conversion, so it will iterate over each column in the data frame, checks if the column data type is object string. Okay, here it will check. Then attempt to convert to columns to a numeric using pd to numeric, causing error to none. If there is error, then it will, this cause will use to use their NaN value. Okay, then if more than 50% of the values are numeric, so here if more than 50% values are numeric, replace the original column with the converted numeric column. Okay, this is what we have right here in the if. What if more than 50% of values are numeric, replace the original column with the converted numeric values. Okay, then let's move to handle our null values. So how we are going to handle null values? So for that we are going to create one function, handle underscore null underscore values. Okay, let me get clear here one thing, that we are only adding or writing here conditions. We are not in a Streamlit. We only use here one line of Streamlit code, that is st.error, st.error. We did not use any Streamlit code or any plotly code or any numpy code to show here our data sets. We did not go to Streamlit. Okay, so inside of handle null values, we are going to pass our def, then what, method, then custom value, that is none. So we are going to pass here one custom value as none first, then we can replace it as per our requirement. Okay, none. So let's write code to handle our none. So first is if method is equal to mean. So what it has written here, that if we choose or user choose here mean value, then what our data frame or what data frame has to do? So data frame has to do use or do this command, that is fill na df dot fill na inside a bracket df of that mean value. Okay, so we are going to use here generalized solution. We are not going to hard code it. Okay, because we are not going to do this for single data set. We are going to code this for multiple data sets. Okay, then if mean, then he has to do with the df dot mean. Then what, if elif what, elif method is equal to what, median. Then what, if the method is equal to median, then same df dot fill na, correct here, fill na as df dot median. Okay, in place is equal to true. Okay, then again elif, which method we left? So method which is left is method is equal to that is mode. So basically mode is used for categorical values. So df dot fill na, what fill na, we are going to use df dot mode value. Okay, so it has to use mode value, but we are going to use in get it in a string. So for that we are going to use iLock and give us 0th position value. So it will return us the exact mode value. Then in place is equal to, so basically what in place is equal to true do, so it will do this permanently, do the changes permanently, not temporary base. Okay, so we are up to mean, median and mode. Then what, we are left with our custom value. So for what, for our custom value, what we go and write elif method is equal to what method, if someone choose custom value, then what, then if someone choose custom value, see control value, then okay, we have to add here one more line or one more condition, that if the user is going to choose custom value, then he is not going to use none value, because the none value we are handling here none values, and if the customer is going or user is going to use again none value, then it did not handle our null values. Okay, so for that we have to add here one more condition, that and that custom value is not none. Okay, so it will handle that error. So it will have to change at df dot fill na with what, with custom value. Okay, comma in place is equal to true. Okay, we are not in Jupyter, so it did not taking an reference value. Okay, if not then he has to return what, return df. So why we are again or every time we are writing return df, that every time after after completion of this command he has to return df. So we can use that df value or data frame in the next lines also, or for next data analysis process also. Okay, so let me explain you first what we have done here. So our function defines that it handle null values, or we have create this function to handle null values in the data frame. So what it will use fill na. So fill null values based on the selection method. Mean fills null values with the mean of the column using df dot fill na inside bracket df dot mean in place is equal to true. Median, which fills null value with the median of the column using this command. Okay, then mode fills null values with mode, most frequent value. Okay, so what is mode? Mode is the most frequent or most repeated value in our data frame, that mostly it is used with the it is not used with the numerical column. It is only used with the object type of data types. Okay, then custom value. So basically what custom value do, so and with custom value we have right here one more condition, that it did not wants or user cannot be use none value here. Okay, fills null values with a custom value provided by the user. Okay, then what, then okay, let's start with another function, that get underscore numeric underscore columns. So we are going to write here one function to get the columns which are numeric, get list of numeric columns. Okay, for that we are going to write one function with the name of get numeric columns. Inside of that we have passed here our df value. So what it has to be written, it has to be written our df dot select, what it has to select d types. Okay, what d types it has to include what is equal to, in a square bracket, np. So we are using here what, numpy, np dot number. Okay, then outside the bracket we are going to write that columns dot to list. Okay, so to list is used to list the result. Okay, so this function get numeric columns to get a list of numerical columns in the data frame. Then it selects columns with numeric data types using df dot select d types include np dot numbers and returns their name as a list. Okay, then get categorical columns. For that we are going to write one more function same as above. Let me copy this, Control C, Control V, and we are going to change it as a get categorical. Okay, get categorical columns. For that I am going to use exclude here. Instead of include we are going to use exclude. So it did not include any column with numeric data. Okay, all is same. Okay, so basically why we are using this, or why we are doing this, or why we created here two functions. So basically we are using this in the, or in, to plot a graphs here. So the next function which is used here, or which we are going to use to plot our graphs. Okay, you can see here. Okay, we have passed here chart type, select x-axis, select y-axis, and color areas. Okay, let me here show you. So for what, to prepare categorical plot data, we are going to, or we are again going to create one more function def with the name of prepare. Prepare what? Prepare categorical plot data. Okay, inside a bracket we are passing def. So below that, this is basically a function. What function? This is the function to plot graph. So in function we are going to get what? X column, we are going to get y column, we are going to get one, okay, we are also going to get aggregation, okay, as mean value. So I am passing here one default value. You can use as per your requirement, or okay, we'll write one condition that we can change aggregate value as per our requirement. Okay, so it will prepare the data for categorical plots by aggregate numerical values. So inside that we are passing if what, df bracket what, x column, what, if x columns data type d type. Okay, here after the d type, what, we are going to check the data type of this column as is equal to object. Okay, and what, df, sorry, df of y column same dot d type what not equal to. So one of column is going to be object, one column is going to be numeric. Okay, not equal to what object. Okay, then what the condition we have right here. Then we are going to write here condition for our aggregate function. If aggregation, if what aggregation is equal to mean, then what, then we have create one here function aggdf is equal to what, df dot group by. So group by is a function from pandas, so it will what we write group by what, group by x column, group by on x column, then in a square bracket we are passing our y columns. Okay, then dot mean, and then again reset index. Okay, so let me explain this up to here. You will get an idea what we have right here or what we have done here. The first, the function prepare categorical plot data to prepare data for categorical plots by aggregating numeric columns. Okay, then aggregation, if the x column is categorical and the y column is numeric, aggregates the y column values based on the y column values based on the selected aggregate method. So which aggregate methods we are going to use here, which are, first one is mean, the second one is sum, and the third one is count. Okay, let me write that, you will get an idea. Let me copy this first, Control C, then enter, Control V, enter. Here I am going to change with the sum, again I am going to change here with the sum, then here I am going to change with the count, then again I am going to change this with the count. Okay, see here we have write three conditions here, then we are going to get our aggdf as a return here. Okay, after the condition we are going to get here our aggdf. Okay, then what, again we want our plain data frame in return for next calculation. Okay, so mean will calculate the mean value of or mean of the y columns for each category in the x column. Okay, and sum calculate the sum value of y column for each category in the x column, and same with the count. Okay, then let's move towards the plotting of graphs. So this is, so plotting of graphs is easy here with the Streamlit. So mostly Streamlit is going to use to plot graphs or plot multiple data types on a Streamlit platform. So Streamlit is used for that mainly. Okay, let's create one function which will handle our graphs. So for that I am going to create def create underscore what, visualizations. You can change the name accordingly, or you can copy paste my code. I am going to paste all the links of this and my Streamlit project, the link in the description. You can copy that all the data sets from Git and link to use that, or you can use to create your own Streamlit web app. Okay, here we have created one function that is namely dev create visualization. Okay, let me check. Okay, visualizations. If there is spelling mistake, ignore that. Okay, here inside df we are passing what df, then what, then we are passing chart type. So basically we are passing this because we are going to create a drop down list using Streamlit. Okay, then comma what, then we are going to pass x column, sorry, x underscore column, then y underscore column, then what last, as color, as I've shown you that we are going to pass color, but we are not going to pass color as a red, white, green. We are going to pass color as another column name. So we can add there multiple column in single plot. So we can handle our data visually better. Okay, so color underscore column. So what is in color column? So color column will going to get none value for now. We can change that, or we are going to change that. We are going to write one function for that. Okay, then for this we are going to use, where we have used aggregation. Let me find that. Okay, here aggregation, here v. So aggregation as is equal to me. So you can copy that this. Okay, so below that we are again going to use try and except block, so it will handle if there is an error. So inside the try block we are going to use if what, x column what, x column and what, x column and y column. So if the function, or if our data frame is having x column and y column, then what, then plot underscore df, sorry, plot underscore df is equal to prepare categorical plot data. Inside of that we are passing our data frame, then data frame, then x column, then y column, then aggregation. Okay, as we have done earlier. Then what, if, then else if, else what, plot data, plot underscore df is equal to df. Okay, if not, do nothing. If s, do, or plot the graph. Okay, then next is what, if. So I'll explain this code too. Okay, so first the function create visualizations to create different types of visualization using Plotly Express. Okay, then data preparation. In the data preparation we are plotting graphs. Okay, if x column and y column are provided here, as if x column and y column are provided, then what, aggregates the data using prepare categorical plot data, otherwise uses the original data frame df. Okay, as we write here. Okay. Then what, then we are going to use the condition, or going to pass here multiple conditions to plot our data sets, or sorry, plot our graphs. Okay, if what, chart type, if the chart type is equal to scatter plot. What? Scatter plot. Then what? Then fig. So fig is used to plot a graph. Fig px dot scatter, px dot scatter instead of scatter plot. First plot tf, okay, then comma, then what? On a x you have to use x column, comma, on a y it has to use y column, okay. We correct this, y is equal to y column, okay. Then color, at color is equal to, it has to use color column, okay, color column. Then for title, let me use this. For title, let me do one enter here, so it will, okay. So for title is equal to, what we are going to use as a f string. Inside of f string we are going to pass our x column. So provide me a, each will provide a title, that provide me x column name with versus what? Y column. So dynamically we'll get a name of our plot, okay. Then we have to write this condition multiple times for every column, okay. Let me write here elif. What? Elif same. What same? Chart type to this, but we are only going to change chart type. Here we are going to use line plot. Line plot. Here instead of scatter we are going to use line. Then all remains same, that is plot df x is equal to x column, y is equal to y columns, color is equal to color columns, title is equal to f string of x column versus y column, okay. So we can do it up to, okay, we'll do this for next two graphs also, okay. Then after line plot, okay, let's use for, okay, we can use bar plot here. Then sorry, let's say, let me correct this with the tab, okay, it's corrected here, okay, it's corrected now, okay. Here then again I'm going to copy this, Control C, Control V, tab, 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 okay. So instead of line plot we are going to use here bar plot. Here also we are going to change it with the bar plot, okay. Then here for line plot we are going to use box plot. Again we are going to change this with the box, okay. So we have write code here for 4 plots, okay. Then for the next plot is what? Okay, the next plot is I am going to use is histogram, that is histogram. Here also I am going to change as, sorry, histogram. So in the histogram there is no y column, it only takes x column, okay. So I am going to remove y column from here, and comma, color will be same, then title will be remains same, okay. Here we can or we can customize our title also. We can use here as box plot of x column versus y column, same as here histogram of x column versus y column. Okay, sorry, same we can plot our pie chart also. Let me copy this, control C, control V. We correct this. Okay, instead of histogram we are going to use plot, sorry, what, pie chart, pie chart. Here also I am going to use pie. Okay, px dot, or what I can say, pie chart. Okay, let me, okay, we can change here. With the pie chart we have to write the code separately. So here we have selected chart type as pie chart. Okay, below that aggregate, sorry, aggregate df. Okay, instead here we are going to use df dot group by. You have to use your group by. In a bracket I am going to pass x column, and again outside the bracket we are going to use y column. Okay, then the sum. So it will help us to plot our what, pie chart. Reset, sorry, reset underscore index. Okay, then next what, figure. We did not plot it our pie chart. So in figure what we are going to use as px dot pie chart. Okay, so inside of pie chart what we are going to use, aggregate df, comma, here we are using plot df. Okay, as we calculated here. Okay, for now, for this pie chart I am used here aggregate df, that instead of plot df. Okay, so inside a pie chart I am using, or I am passing first aggregate df, then comma, then I am going to pass values as is equal to y columns. Okay, then at names is equal to I am passing x column. Okay, and title will be same, control C, control V, pie chart of y columns. Okay, okay, I think we have plot our all the graphs that we want to plot. Then okay, we are left with the one more plot, that is count plot. I think this is also important. Okay, let's write for plot graph. For that I'm going to copy this line, control C, control V. Here I'm going to change this chart type with the count plot. Okay, count plot. Below we are going to use count df. For this I am going to use count df is equal to df in a square bracket we are passing x column. Okay, then what, dot values underscore counts. So it will count the unique values, value underscore counts then comma reset index, then again what, count df dot columns, that is count df dot column is equal to what, x column dot x column dot, or comma count. Okay, let me write this first and I'll explain you below. And let me plot a figure here. Inside a figure we are using px as a plotly dot, we are using what, count. So count plot, we are using a bar plot. Basically bar plot is used for count here, and then inside then I'm using count df first, then x as a x is equal to x column. Okay, x is equal to x column. Okay, then on y, what, we have already calculated our count. Okay, count, let me write this. Okay, count. Okay, then title will be count of x column. Let me copy this, Control C, Control V, count of x column. Okay, I think we are up to okay. Let's move to the next line. I think we have plotted here multiple graphs. Let me explain you. It will create a different types of visualization based on the selected chart type. So what we have here as a selection, we are having here first scatter plot, then line plot, then box plot, then histogram, pie chart, count plot. Each type of plot is created using Plotly Express with appropriate parameters for x column, y column and color column. For pie chart, here for pie chart aggregates the y column values for each category in the x column. For count plot, here last for count plot counts the occurrence of each category in the x columns. Okay, then let's plot the graph. So we are going to use a generalized solution, that is figure dot update layout, update here update layout. Inside update layout you can see here we have to pass self, dictionary 1, override and keyword argument. Okay, so inside a layout we are passing first enter. So what we are going to use template. So at the place of templates we are going to use as Plotly white. Let me write this, I'll explain you. Plotly underscore white. So template sets to Plotly white. Then what, x-axis title, what, x-axis underscore title as x column, x underscore column. Same y-axis title. Sorry, Control C, Control V. Okay, column as y underscore column. Okay, then I'm here comma 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 Then what? Then on x-axis, what? What on x-axis? What I want? I want what? Categorical order. That is categorical. Sorry, categorical order. Let me write this first. category, then order. Okay, order. So what it will do? If the x-axis or x column is categorical, sorts the x-axis categories in descending order of the total columns. Okay, here. Then on a curly braces, total descending, as we said here, descending order. Let me pass here one, sorry, total descending. Okay, total descending. Okay, outside a curly braces we are going to write if what df of what x column, what df of x column dot d type. So this is a pandas command which will check the data type. If the data type is equal to object. Okay, only when the data type is object, the category order will be in the descending order. Okay, so just it is for just to show, nothing else. It will show our all the categorical values in the descending order, or else none. Okay, then else none. Okay, the next if what df of x column dot t type is equal to object, then what is equal to object, then what is wrong here. If df of x column dot d type is equal to object, then what figure dot update, what update x axis. Let me take this from here, x axis, and inside we are passing our rectangle, that is the problem. Okay, x, sorry, x not x, that is TICK angle, tick angle is equal to 45. Okay, then what return figure. If not, then the last our exception block as except what, exception as e st dot error. So what we are going to pass in error, that f string dot, sorry, f string in quotation mark we are going to use as error error creating visualizations. Okay, then in curly braces str in the regular bracket e, okay, bracket close, curly braces close, then quotation mark close, then regular bracket close, return, then if not return none. Okay, we have up to this. Okay, okay, so this will handle our error which catches any expectation or exception that occurs during visualization and displays an error message using st.error, returns none if there is nothing on error. Okay, so let's head towards the this section where we are getting this section. Okay, the raw data, data insights, shape, or all this summary, all these values. Okay, let's collectively create that. Okay, for that def show data insights. Okay, def show data gsts. Okay, data insights. Okay, I'm passing data frame. Okay, for that I'm using st dot subheader. So from this point we have writing our all the coding related to our Streamlit program. So it will use to plot or create a web application using Streamlit. Okay, so all these created functions we are going to use here. So at subheader what we are going to pass as data insights. Okay, data insights, then what, then next, okay, sorry, data insights, okay. Then enter, then st dot write, st dot write what, so inside a write we are saying that it has to show data set shape. Okay, data set shape. Okay, so it has to show this on our website. So and in return what, in return what we want as a df dot shape value. Okay, next is st dot write. So what write we are going to use as data types, data types. For that I think we are have to write here one loop, so it will show data types of each column. Okay, st dot write, then inside a bracket we have write data types. Okay, then below st dot write, so what write, he has to write df dot d types, so it will show all the data types. Let me show you here. Okay, this section. Then let's head towards the next, that is what, okay, let's get some numerical column first. I think we have write one function to get numerical columns. Let me create one object here, numerical underscore calls is equal to get numerical columns. Okay, inside of that we are passing our data frame, so it will collectively get all the numerical columns from there. Okay, so you'll better get idea now, so why we have write all these functions separately instead of creating in once. Okay, so Using that reference, we are going to plot here our Streamlit code. Okay. So here I am going to write one function, if function numerical calls, if numerical calls dot st dot write what st dot write. Let me show you. So it has to write this summary statistical columns. Okay, let me copy this summary statistical columns. Inside of that, what we want, st dot write. Inside of that, I want df of what? Df of numerical columns. Okay, df of numerical columns and describe that. Okay, so basically describe is a pandas command which will describe all the numerical columns. Okay, then for what? For categorical columns. For categorical columns, we are close this, enter for categorical calls, same as above. Get categorical columns passing df. What is the problem? Let me close this and again open this. Okay, here, just a second. I don't know what is the problem. If you know how to resolve it, please comment it. Okay, here categorical column, then we are going to create one again a function or if function or loop. If categorical calls, enter st dot write. Okay, same as above, st dot write. And what we want st dot write, we want summary of categorical columns. Okay, summary statistics of categorical columns. Okay, categorical columns, and then what? St dot write. So what we have to write, st dot sorry. So we have to write for each column. Let me write for call in categorical columns st dot write, because it is not a numerical column, st dot write upstream using slash each on a new line that unique values in each column. Okay, then enter st dot write in a bracket, we are passing df with call. Okay, then it will values. So basically values underscore counts is used to get value underscore counts, it used to get unique value dot head. So head will show top 5 of. Then in last we are writing st dot write in bracket missing values, missing let me write with the underscore values. So okay, missing values. So how you going to get missing values? St dot write in a bracket df dot is null dot sub. Okay, we are up to our basic pandas command that is used for data analysis. Let me explain this code and then let's head towards the plotting graph. Okay, so the function defines first data show data insights to display basic insights about the data. It displays various insights about the data sets. Okay, first dataset shape displays the shape of the dataset, number of rows and columns using df.shape. Then data types displays the data type of each column using df.dtypes. Then summary statistics, which will display summary statistics of numerical columns using df of numeric columns dot describes. Then categorical columns analysis, which will display unique values and their counts for categorical columns using df of calls dot values underscore counts dot head. Then for missing values, which will display number of missing values in the each column using df.isNull.sum. Okay, okay, now let's give us or write one main function which will display our all the code, all the Streamlit code, df of main. Inside of that, see, inside of that we are going to use st dot set. What? Set page config. Okay, so inside we are going to write page page title. So what the page title we want as data analysis tool. Okay, then comma, then is equal to layout is equal to wide. Okay, layout is equal to wide. Okay, so it will take all this length, whole length. Okay, let me copy this. It will help us to write some code. Okay, then st dot title. What title? Interactive data. Let me write st dot title. So what title we want? We want this title. The first one is our data analysis tool. The second one is this interactive data analysis tool. That is sorry, the title we are going to use. Then what? st dot write. So what we going to write is this. Okay, this. Okay, then next. Okay, first we have created here one main function that sets up Streamlit interface. Okay, as I said, then page configuration sets the page title and layout for the Streamlit app using st.set page config. Okay, then title and description. So displays the title and description of the app using st.title and st.write. Okay, then we head towards the upload our file. Okay, then upload file. Let me upload underscore uploaded file. So what is uploaded file? Uploaded file is equal to st dot file, not a file uploader, st dot file uploader. So which file uploader? We have to send one message there, choose a file, that is choose a file that is having type is equal to, in square bracket, first is CSV, then comma, choose a file. We correct this. Okay, then Excel SX. Okay, then last, oh sorry, last one, second last, XLX. Okay, then comma, the last one is JSON. JSON. Okay, this is the file uploader, which will create a file uploader widget that allows user to upload a file, which is CSV, Excel or JSON, using the st.fileuploader. Let me show you here. This section, drag and drop CSV file for this. Okay, the next, towards the next section, set towards the next step. What if uploaded file is not none? Okay, then what? If the uploaded file is not none, means we have get everything that we want, we have uploaded our data frame. Then what? df dot load underscore data as bracket uploaded file. Okay, uploaded file. Okay, then below we write one condition, if df, what? df is not none. If df is not none, then what? Then if, okay, sorry, let me correct this, we have to use here is equal to, okay, enter, then if df clean underscore data, okay, df is equal to clean data bracket df. Okay, let me see first what we have write in a clean. Here, clean data, this is our first function. Okay, so it will operate here. Okay, so below that we are using st.subheader, st.subheader. Inside of subheader we are passing the raw data preview, that is, it will show data as it is. Okay, raw data preview. Okay, the next line will be st.write. What we are going to get as a result in st.subheader result, that st.write, what write? It has to write df dot head. Head will show top 5 values. Okay, then below show data insights, inside a bracket we pass df. Okay, then again we are writing st.subheader. Okay, st.subheader, inside that we are passing data cleaning. So below, inside data cleaning, we are going to write st.write again, st.write. So inside st.write we are passing number of null values in each column. Okay, so what result we want? Number of null values in each column. Okay, this is what I want. Okay, see, sorry, as a result what it has to write? st.write, in a bracket we want df dot is null is null dot what sum. Okay, this is what we want. Then null underscore method, then null underscore method is equal to, so what is null underscore method? Basically this is used for handling null values. St dot selection box. So this is used for create a drop down list in Streamlit. Okay, then right handle null values comma square bracket what was null. Okay, first we want none in comma, then we want what mean comma, what we want median, then what, then we want, first we want none value, then we want mean value, then we want median value, then we want mode value, and what we write there, I think we write here custom value also. Yes, custom value. Custom underscore, sorry, custom space value. Okay, this is what we written above. Okay, let me check this first. Null underscore method is equal to st dot selection box. Okay, sorry, select box in the regular bracket, it will handle null values. Okay, let me close this. Okay. The error will gone, and I think we did not close here square bracket. Okay, all the error will be resolved. Okay, then we have to write a function on our null method. What if null method, what if null method is equal to custom value, then what, this custom value, let me copy this, Control C, V. Then what, then I think we have created one function over for our custom value, then what, custom value is equal to st dot text input the bracket enter custom value, enter custom value. Okay, so basically this is used to get a user data or get an input from user. Okay, then else will be for custom value is equal to none, custom, copy this, custom value is equal to none, and I think we have write one code also to handle this custom value will not be none. Okay, then next if what, st dot button, right, for what we are going to use apply null handler, so which will be used to as a create a clickable button. Inside of that we are writing apply null handling. So set after the if, to write one condition that if df is equal to handle null values, we have already created this function above, handle null values, inside that we are passing df, then we pass null method and then custom value also. Okay, then st dot write, what, st dot write it has to write null values handled successfully. Null values handled successfully. Okay, let me explain this first. So this is data. This is used for data cleaning, which displays the number of null values in each column using df.isNull.sum. Then null value handling, which allows user to create or to select a method for handling null values, which is from mean, median, mode, or any custom value, which is we are going to get from user by using st.select. Then if custom value is selected, then allow users to enter a custom value using st.text input. Okay, then applies the selected method using handle null values when the apply null handle button is clicked. Okay, as we created here a st.button. Okay, then let's head towards next section, that is st.subheader. st.subheader. Inside a subheader, what we going to do? We are going to do as a write data visualizations. Okay, this is our last, I think last, yes, last visualization. Okay, so here we are going to create three columns. First is call 1 comma column 2, then column 3. So Streamlit will use columns to divide this section in 3, 2, 4 or any number of columns. Here we have used 3 columns. So this is the first column, which is used for select chart type, the second column which is used for select x-axis and y-axis, and the third column which is used for select color or aggregate function. Okay, as we seen earlier. Okay, let me write code or write all the commands for all these columns. Okay, st dot columns, and inside a bracket we are passing that we are going to create 3 columns. Okay, then it will automatically change our web address into 3 section. Okay, then for first column, what we want in a week, call 1, that we want what we want one drop down list which will show or which is select chart type, which is used to select chart type. Okay, then what here it is used for chart underscore type. Inside that it has one selection box. Okay, as I said earlier, then curly braces, then select type, comma, then with that it has bar plot. First it has bar plot to select. Okay, then comma, then it has scatter plot. Then it has, let me copy this one by one, plot, line plot. Let me copy this from here. Here it goes, column. Here. Okay, here we call receive. So as a result, it will use st dot selection box. Inside it will select chart type. Let me correct this here, so we will get idea. Select chart type. Okay, then we create one square bracket, and inside of square bracket we pass all the name of plots. Okay, then with the second column for with call to, sorry, with call. So what we are going to write or get in call to, so basically we are going to get select x-axis and select y-axis section. So with call to, so we are getting or numeric columns is equal to get numeric columns, and we are passing df here. Then categorical columns, for categorical columns we are passing here get categorical columns, again we are passing df, then all columns is equal to df dot column dot to list. So it will create a list of all the columns. Okay, then if what, if chart type, if our type of chart is chart underscore type is equal to count plot. So this, let me copy this here, Control C, Control V. If the selection is our count plot, then what, then x column, x underscore column is equal to st dot selection box, st dot selection box give me a drop down list for of select category, of select category. Okay, which category? Categorical columns. Okay, so when we are going to plot a count plot on x-axis, we are going to get categorical columns, and y-axis, sorry, y column should be none. So we have to remember that whenever we are going to use count plot, we did not going to use any column on y column. Okay, or not going to select. Then elif means the second condition, if chart type is equal to histogram, then what, then on x column should be or must be st dot selection box in a bracket, we are passing select column as what, all columns. Okay, with the histogram, x-axis will automatically select all the columns. Okay, and then y-axis will be none, sorry, y column should be none. Okay, then again we are going to write for our pie chart, that is else condition. With else condition, else what, else on x column, what we are going to get, we are going to get st dot selection box in bracket, what we are going to write as select x axis. Okay, select x axis. Okay, as all columns. Okay, then let me select chart type. If chart type is equal to pie chart. So basically we have given here one condition that whenever x axis is going to select all the columns, then we are going to use our pie chart. Okay, and inside that pie chart we are going to write condition for our y column only. So let me copy this, Control C, Control V. Here I'm changing for y column. Instead of y columns we are going to use here numeric columns. Okay, so y column is equal to st dot selection box in bracket select column, then select values as numerical columns. And in else also, let me copy this line, Control C. What we are going to write as else, in else we are going to write as a y column, it has to use again as st dot selection box, but here he has to choose one y axis. Okay, here he has select, that means the x-axis is as selected, the y-axis is also as selected. Okay, then head towards the last column. Okay, now we are only left with column 3. So with column 3, inside of that we are going to write if chart type not in what pie chart and count chart, pie chart and count plot. So pie chart, and the second one is count plot. Then what? Then color column, color underscore column is equal to not as st dot selection box or select box inside a bracket we are going to write as select color column, select color column in bracket optional. So basically it is optional, it is not a mandatory thing. Or if it's optional, then it has to be selected as none. Okay, with the plus we are going to write as categorical columns, so color column is equal to st dot select box inside a bracket we are passing select color column. Okay, you can make it capital also, this is not the problem. Then in a bracket we are passing optional, so it is optional thing, we can select this or we cannot. Okay. Then here none. Okay, then after none we are also passing the, we can select also categorical columns also. Okay, then below that, what is color column? So for color column we have none if color column is equal to none. Okay, else. So basically what we have done here, we have pass here one default condition or default value to our color column. Okay, that is, if nothing is selected, then he has to select a default value as a none. Then if x underscore column in categorical columns and y underscore column in numerical columns, then what? Then aggregation, what? Aggregation is equal to st dot select box, inside a bracket we are passing select aggregate method, same as above. Select. So we are creating one more drop down list here. Here we have created one for color column, then we are going to create it one for aggregate column, so aggregate. So basically what we are going to get in the aggregation drop down, that is if x column in categorical column and y column in numerical column. So when this is going to be happen, or whenever this thing is going to be happen, there we are going to get our aggregation drop down list. So inside of that drop down list we are going to pass select value, that is default value that user going to see, that select aggregation method. Okay, if is equal to, inside of square bracket he is going to select value from mean, sum or count. Okay, as we write above in the aggregation. Okay, or we can select a help. Let me write this, then I'll explain it. Help is equal to how to aggregate numerical value for each category. How to, take this below. Okay. How to aggregate, how to aggregate numerical values for each category. Okay, then next, if this is not going to be happen, then we have to write condition for our else. What is else? That then he has to be default value, that is aggregation has a default value as mean. Okay, then else for our main condition, else what? Color column. So basically first if is for color column, second if is for color. So in inner if is for aggregation. So we have close here if and else, then we are writing else for our first if. So here we are passing that color column, color underscore column, copy this, control C, control V is equal to none. Okay, then aggregation also, control C, control V is equal to sum. So whenever our color column is none, it's going to get our aggregation value as sum. Okay, so we are up to this. Let me explain this. For data visualization, Visual provides option for creating different types of visualizations. Chart type selection allows users to select the type of charts from bar chart, scatter plot, line plot, box plot, histogram, pie chart, count plot, or what we are using here selection box. Okay, then after the count selection, user allows to select the columns for x-axis, y-axis and color if applicable using selection box. As we can say, we have right here to select for x-axis, select for y-axis, then here we have also right for our color column and also for our aggregation method, that is categorical plot using selection plot. Okay, then let's head the next. Then here figure is equal to create visualizations. So it is for create our visualizations. So instead of that, we are passing our def, then chart type, then we have to select our chart type, then we have to select x column, then we have to select our y column, then we have to select our color column, then also we are going to select our aggregation. Okay, these are the values that we are going to select to plot our figure. If figure or fig is not none, then what? If figure is not none, then st dot plotly. Okay, sorry, plotly chart inside a bracket fig. So this will going to accept all the values of this that we have passed here, then comma use container with true. So what it will do, it will select all the distance or all the full width of this container tag. Okay, then so what we will create, it creates a selection or selected visualization using create visualization and displays it using Streamlit plotly chart function. Okay, then let's head towards the next line, that is st dot subheader. Inside a bracket we are passing data filter. For data filtering, so we are going to write selected or selected underscore columns. Sorry, let me correct this. Columns is equal to st dot multi select, st dot multi select. So it will select, we can select here multiple values. So from which values? So first we write here one value which will display to the user select columns to display. So this is going to be shown user whenever they are inside of this block, and from which values they are going to select, from def of columns dot to list. So here they are going to get one list of columns. From that column list they are going to select multiple columns. Okay, also we are going to write one default value. Default is equal to we are going to pass here all the list, so they can select or deselect as per their requirement. Okay, then let's head towards the next line. So we are up to our with column 3. Then we have write our condition for our fig, where we have plotted one fig here. Then we write a condition to plot our graph, or sorry, subheader section, where they can select multiple columns. Okay, then we also write a here condition. Okay, st.subheader data filtering, sorry, select columns st dot multilist. Okay, sorry, multi select. Then inside a bracket we are going to pass as select columns to display with comma df columns to display. Okay, to list. Okay, we can say that, or else we are going to pass our default value. Then we are going to, I think this needs to be added inside of this, control X, then to list. If this is not selected, then the user has to select this default value. Okay, I think now it's corrected. Okay, let's head towards the next section, that is search term. Search 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 term is equal to st dot text input, text underscore input. Inside a bracket we are passing search in data. So this is the message that we are going to show user, search in data. Okay, then this is for the text search. Okay, then we are now head towards the filter data based on the selection and search. Let me write filtered df, that is filtered underscore df. So what we are going to do here, we are going to create one df function so that we can download easily as per our requirement. We are going to select there the columns that we need as our final output CSV or any files in the any format we can download that. So for that we are writing here one function that we want this mult or this kind of or this type or this number of columns in our result CSV files. So for that we have created here one object as a filtered df. Inside of that we are passing df in square bracket selected columns. So this one is selected columns. So all the selected columns will be inside of this. And if search term, so as per their search or as per user search term is filtered data, filtered df is equal to filtered df. If it matches, then what, then sorry, then filtered df dot as type what, as type str. Okay, then apply what, apply one condition, that is lambda. We are going to write here one lambda function, lambda as x what, so provide us a str value with which contains search term and case is equal to false. Okay, so we have created here one filtered df, so which will return only the values that are selected by the user. Outside of that we are dot any in bracket axis is equal to 1. Okay, that's it. I think we do not miss, square bracket is closed here, the first, this bracket is closed here, second one is closed here, think this one, okay, this one is left. So we can let's type, okay, I think we did not need to be this, okay, now it's corrected. Okay. Now to show filtered data, we also want to show the filtered data to the user. So for that, st dot write, in bracket we are passing our filtered df. Okay, so it will show all the selected columns to the user. Then below that we are writing st dot write. Inside of that we are passing our filtered df here. Okay. Let me correct this. Here we are going to show user only that this text, and here we are going to show the value. Okay, then now we are left with the one, or our last thing, that user can able to download that file. Okay, for that we are going to write st dot download, download button. So for that we are going to create one button section. So inside of that, enter label. Label is equal to what label we are going to show to the user, that download filtered data as CSV. Okay, so download filtered data as CSV. Okay, the user is going to see this message. So why we are using CSV here? Because 95% of times we are using CSV files in this data analysis tool. So for that we are going to use comma, then what, then data. So which data they have to show, or they have to download in the download button, that is filtered data. Okay, then he has to be converted to CSV. Okay, so basically this is the pandas command, which will convert the data frame in CSV format. So we are passing index is equal to false. Okay, then we are again going to use one Python command as encode. So it will help us to convert our file in CSV format, UTF-8. Okay, then again comma, then next value is we are going to pass as file name. So which file name the user needs to be, or user going to get? So he is going to get filtered data, or filtered df.csv. Okay, so this is the final, or this is the final CSV file name they are going to get in their download box after the download. And then the last line is mime. So mime is equal to text slash CSV. That makes the new everything. So we are headed to this. Then we are left with the 2 line of code. Let me explain you first what we have done to this. Okay, so for this, or data filtering, let me show here. We have filtered df, that is, which provides option for filtering the data. Okay, here we have created one function as it will provide an option to user which they can filter their data, and then allows users to select the columns to display using st.multiselect. So we are allowed here. Then text search. So what it will do, it will allow users to search for specific term in the data using st.select input. So they can, if there are multiple columns and they want a specific column to be selected, they did not want to go or scroll up to down, So for that we have created here one search box so they can easily search that value. Then the next is filter the data. So here, as we can see here, is filter data, which will displays the filtered data using st.write filtered d and provides an option to download it as a CSV file using st.download button. Okay, as we created here. Then last, if underscore underscore name underscore underscore is equal to main function as underscore underscore main underscore underscore what main. So basically this will return a one value which is true value. Then all the main will be run automatically. Okay, we did not have to has to call every function. Okay, as we or as everyone know, the main function is used for that. Okay, so whenever we run our script, the main will automatically executed. Okay, let's run this and see what we are going to get. So okay, to run our CSV file, sorry, to run our Python file, we need a command prompt. Then on a command prompt we are going to pass as Streamlit run, then data.py. Okay, this is our final result we are going to get on our dashboard. Okay, let's see. After uploading one CSV file, or okay, let's upload this sales data .csv. What we are going to see, we are going to see our raw data here, preview here, then data insights, which will show dataset.df or df.shape value. Then here we are going to see our data types of each column. Then we are going to see summary statistics of our numerical column, then our categorical columns, each one by one. Okay, then data cleaning tools, which will show first that it did not have any null value. Then here we can select to replace our null value as from these 4 or 5 drop down is that none. We can select mean, median, mode, or custom value. Okay, then apply, and we can select here multiple plots. Okay, as per our requirement it will change automatically. It did not take any time to show. Then our last as a data filtering, where all the multiple columns are automatically selected. You can see here we can search here, that is our text box. Then we can easily download our filtered data as CSV file. Here you can see the name of the file is filtereddata.csv. Okay, now I will show how to upload this project on Streamlit platform. Okay, for that we want a one requirement.txt file. Okay, let's head towards our Chrome. Okay, here on Chrome, okay, let's go to the git repo, github. Then okay, I will upload this on this data analysis. Okay, here I am having one, but already having here one py file. Okay, okay, let's delete that and I'll show you how you can upload one file also. Okay, so to delete that, let's delete this first. Can delete this from here, delete, commit changes. Okay, let's then in requirement.txt what it has. If we did not want open XLR or scikit-learn, or we did not use any scikit-learn scipy. Okay, then okay, for that to upload a file or upload a project on Streamlit platform, we need two files. First, the first file is we need on a Git repo is our py file, and the second file is requirement.txt, where we are going to told our web app or Streamlit that these four or these five or this number of files, or we can say that this number of applications we want to be installed on our Streamlit platform to run my Python file. So for that we did not want any reportlet or plotly. Okay, we want a plotly, but we did not want scikit-learn, scipy, or open excel. Okay, let's let it as it is. Then I'll use commit changes. Okay, then to upload our file, what py file. Okay, I'm going to select here, then upload file, then let me minimize this and okay, use this. Then we are going to upload data.py file. Okay, where it is, data. Okay, here data.py file I'm going to upload here. Then let me, okay, it is uploaded. Then do the commit changes. Okay, then I'm going to go on a website of a Streamlit platform. Okay, streamlit.io, Streamlit platform. So after the login, you are going, let me show you, let me log in again. Okay, sorry. Okay, these are my apps already available on that platform. Okay, after the login, you're going to see this page. These are my projects that I have done or that I have created using Streamlit platform. Now let's head towards to how we are going to upload our Streamlit project on a Streamlit platform. For that, first you have to log in using Streamlit, or we can use our regular Git login credentials to log in on a Streamlit platform. After the login, you are going to see this create app button. So after clicking on that, we can select here deploy a public app from GitHub. Then we are going to select a repository. So in which repository we have uploaded our project as in data analysis project. Okay, here it is, we can see in data analysis. So as I selected data analysis, then it will select which branch. So branch will automatically selected. Then we have to select our py file. So py file name is data.py. Then we have to select one domain name for our URL, so or our app URL. Okay, then I am going to put my name here. Okay, data analysis.pm. Then I'll select with the profile. Okay, so data analysis profile. So domain is available. Then let's deploy this. Okay, it will take 2 minutes of time. Then it will upload our all the requirement. First it will install all the requirement.txt. You can select this button and you can see how our application is going live on a server, or how our application is going to be installed on a server. Okay, you can see here it is downloading or it is installing all the libraries that we are mentioned in our requirement.txt file. Okay, after that taking it on. Okay, now you can see here we are live on our Streamlit project or Streamlit app, where we have this domain name. If I give this domain name to you also, you can easily access that and do all this. Okay, let me upload one more file here. We are going to upload one Excel file here. Okay, let's see. We have here one uploaded Excel file which will show this. It has this float value, then here all the numerical values, then this will show the missing values, then this data cleaning section, then apply null. We are going to pass mean value, apply null section. It will apply, it will running. Then all the result will be changed as per mean value. Okay, it's showing an error. Okay, let me change this to none. Now it will, okay, it's done now. Okay, then here we can change our scatter plot also. We can change to line plot. It will change the value accordingly. We can change the values from here also, as per the, okay, you can see here it is changed their values. You can see clear. Okay, then all the values will be selected here, and then we can download our CSV file as a filter data one, as I am having already one file with the name of filter data. Okay, that's it for now. Thank you for watching. I hope found this tutorial helpful. Don't forget to like, share and subscribe for more data analysis and programming tutorial. If you have any questions or suggestions, feel free to leave comment below. Happy coding and see you in the next video. Thank you.